Hello everybody, welcome to this pitch as part of Splunk Besides 2022. Good morning to those who connect from America, good afternoon to those who connect from Europe and Africa, and good night to those who connect from Asia or Australia. I am Giuseppe Cusello. I'm speaking to you from Italy. I live in Cerveteri, near Rome, facing the sea. I am a 62 years old engineer and I've been working in the IT world for over 30 years and in the cybersecurity world for 11. I'm also a consultant on the issues of governance, risk and compliance and an auditor on the issues of privacy and ISO 27000 compliance. Splunk changed my professional life and my career 11 years ago. Today, I am a Splunk architect working almost full-time in implementation of Splunk Enterprise and Splunk Enterprise security systems. I am a Splunk Trust and I am the coordinator of the Roma Splunk user group, the only, hopefully, only for now, Italian Splunk user group. I've been participating for some years in the live activities of the Splunk community, and I have a lot of fun doing it. This pitch is entitled The Holistic Approach to Data Integration with Splunk. That is, in simple terms, how me and my colleagues have solved the problem of integrating different and heterogeneous data with Splunk. Today, I will talk to you about a problem that I constantly find in my activity as a GRC consultant and auditor, and how we have faced it and solved it in our company. As you can read in the event summary, governance, risk and compliance, GRC, is a crazy land of multiple heterogeneous, non-integrated and 4G only tools. I think that all of you experienced this problem. Have you ever tried to have a quantitative and unified view about all risk posture? Do you remember the ginormous Excels, reports, and tables you were pulling together? Using Splunk, me and my company experienced this problem many times in our daily activity. We are specialized in security consultancies and system integration. For example, we usually have to manage multiple outputs of heterogeneous tools and systems. For example, asset management, vulnerability assessment, APM, taxonomy, business continuity, risk quantification, and so on. And we always need to correlate them to allow an easy navigation leveraging the unparalleled capabilities of Splunk Data to everything platform, a little spot for Splunk. To solve this problem, we created many modules and apps to engineer data integration and specialized views for executive risk managers and geeks, aligned with the main frameworks existent, NIST, ISO 27000, GDPR, and so on, delivering a quantitative view of your GRC world. But what is the challenge we have encountered and we believe have overcome? At first, obtain 360 degrees visibility on the interactions between business processes and technological assets. Remember this, we are not only speaking of technology, we're also speaking of processes and people. Then correlate information on different levels, both for operators, analysts, CISO, auditors, managers, executive, and so on, of risk evaluation carried out, IT assets, IT applications, business continuity, that impact the value chain, accessible to the key people involved in risk management processes, risk management, cost compliance, IT security, and so on. What are the main problems we encountered? First, all the monitoring systems have their own console, and operators have to continuously switch between them to make their daily work. Second, all the monitoring systems usually have dashboards only for operators and analysts, and never for managers and executives. For example, we worked on anti-fraud systems and we didn't find a dashboard that says to managers and executives how much money the system saved and therefore how quickly the system paid for itself. Third, data can be different or similar, and they come from heterogeneous systems. For example, risk quantification from specialized products, from service platform, from CMs, vulnerability assessment systems, and so on. There are many types of data, apparently similar or the same, that are actually generated and presented in completely different ways, formats and metrics, such as, for example, cyber risk quantification. We are speaking of a problem analyzed by operators and associations as Gardner and Clusit, and they found that by 2025, 25% of spending on security services will be allocated to the implementation and maintenance of a trust framework, where, in addition to IT security, it will be necessary to adopt a strategy that provides for organizational intervention in order to transform processes and manage change, in a context dominated by an high independence between functions and organizations. By 2023, third-party functionality orchestration will be listed as a critical requirement in more than 75% of requests for proposal related to fraud detection systems, which is an increase from less than 25% today. So, what are the main requests that arrive from the market? Customer referring to the large enterprise category needs to bring together information on the status and level of maturity of IT processes and infrastructures, from the various company areas to support those areas of governance and control that have the mandate to guarantee risk measurements and governance of controls, capable of representing the operational risk to top management and board. These information flows must be as consistent as possible with the company reality in its complex articulation. The main difficulty is that is generated lies in the distance that exists between the operational areas, IT security, software development, and so on, and the governance, risk management, and internal audit areas. The amount of information grows with the growth of the company, as does the complexity and articulation of the integration processes deriving from acquisitions that pose problems of homogenization of production processes and risk assignment, giving rise to an ever-growing need to be able to perform objective assessments at operational level, a fundamental condition for making objective and timely decisions. The evaluations and surveys of the indicators require time and resources, constituting a growing expense item as the size of the company and the needs to adapt to standards and regulations grow. The main difficulty is faced by the governance and risk management areas of large and medium enterprise companies, is therefore represented by the amount of heterogeneous information from which we start to calculate the performance and risk indicators necessary to be able to undertake risk mitigation and safety improvement. This information is processed by different areas with different methods. Therefore, it becomes more and more complex to be able to give a level of reliability of the data and/or identify refinements in the method of collection, aggregation, and definition of the synthetic data constituted by the indicators. Similarly, the operations areas have the difficulty of providing summary data for evaluating the IT infrastructures to the compliance and risk management areas in compliance with what is requested. This distance between business areas introduces possible errors of assessment, increasing the risk that decisions, both in terms of policies and guidelines that are issued, and orientation for investments aimed at continually improving the posture of IT infrastructure. Errors are made based on information that is not perfectly consistent with the company reality. This complex process often runs into limited budget and resources. So, we search the solution that guarantees data ingestion, normalization and indexing, data correlation, dashboards for all levels of users, machine learning algorithms and statistical inference techniques such as cluster analysis to increase the ability to identify trends and anomalous situations. So, the search was easy for us because we have a long experience and knowledge about Splunk starting from its beginning. Concluding this introduction to the problem, we can say without fear of denial, Splunk with OLOS represents a natural evolution of the digital modernization process and becomes an integrated system to promote knowledge to the decision makers of the client company. Because they reduce the distance between the operations areas and the governance and risk management areas, increase the confidence in the construction of the KPIs and KRIs necessary to be able to decide of investment strategies for the mitigation of operational risk. Innovative means of making available information normally distributed between the various business areas, allowing analysis and monitoring of the posture of its infrastructure based on objective status. And the result is that they give to customers and system integrators savings in terms of dedicated resources and time to obtain information. Okay, let's now enter the description of how the idea was born and how it evolved in its practical implementation, technically analyzing some of its constituent items. The starting point was obviously the idea itself, arriving from the management to create our own platform. A pressing need from some of our customers, the experience of us consultants, willingness to create a niche product that meets these needs. Then we passed for the requisites definition. Then we passed for the problems analysis and the solution global design. Then we found that a model definition and the conceptual design were mandatory to design a solution to be truly effective, problem solving, and fully hit the set objectives. Obviously, not always a small company can afford the investments necessary for the realization of such a product. So we started looking for, and we found some customers who were sensitive to the problem, and therefore bought the first applications of the solution. At this point, it was possible to tackle the technical design of the solution in its complexity and its modules and dashboards. At the end, the development of all the modules using Splunk Enterprise. In the following slides, we will go into the details of each phase by analyzing the steps taken and the solution identified. As already mentioned, the idea behind the development of our approach was based on the following principles. In addition to constituting operational tools for the technical areas and anti-fraud teams, all OLOS components will have to contribute to the formation of a decision support platform for management. Focus must be on primary business processes, with the idea of creating a governance system capable of giving a 360 degrees views of how much IT items contribute to mitigate the operational risk, or how much they raise it. 360 degrees view of contribution and criticalities that IT systems guarantee to the primary business processes, highlighting of processes subject to business continuity, IT applications subject to risk evaluation that support the processes, assessment of the posture with respect to vulnerabilities on IT assets that support applications, view of compliance with the regulations or reference standards in terms of maturity evaluation. But what were the requirements that were identified at the beginning of the project and that are continually being expanded in our day-by-day activity? Implement continuous monitoring of business posture and the level of maturity of IT systems. Provide a tool for the continuous assessment of the IT risk of corporate structures and external suppliers. Provide tools for convergence between adopted standards and the regulatory requirements, for example, ISO 27000 and NIST regulations. Mitigate the gap between the assessments carried out by the corporate areas dedicated to compliance and those of cybersecurity and IT security. So, the goals to satisfy our requirements were collecting and correlating key information related to different types of risk, cyber, IT, business continuity, and regulatory. Enriching the model with information from IT company systems related, for example, to business processes, application portfolio, and IT resources. By monitoring and tracing the evolution of corporate cyber posture and maturity to link the controls applied to different standards. By consolidating the information collected in a centralized repository to allow comparison over time. This approach gives advantages for the customers: reduction of information collection time for the establishment of risk indicators, increasing confidence in the summary data produced, generated directly and not through different passages between different company areas, the availability of comparable data over time and in any case re-evaluable in the event of changes in the complex aggregation methods, the reduction of the efforts necessary to supervise the evaluation and control processes, the availability of a system capable of supporting managerial decisions. But there are also advantages for the developers. With ready-to-use ingestion features, inputs, parsing, indexing, with ready-to-use normalization structure, with predefined data correlation mechanism, with many dashboards available as is and/or customizable. In few words, a platform to integrate different and heterogeneous data flows. To face and solve a complex and, above all, articulated problem, it's necessary to define a logical model of the data flow to be integrated, to define the interrelationship and therefore the correlations. The starting point of a logical model is obviously the primary business processes that organize and govern the data flows. Therefore, the IT infrastructure supporting the business processes must be examined in terms of infrastructure and applications. Hence, the IT assets and the applications. Linked to the applications, there are usually the data that are basis of the risk analysis, and therefore the vulnerability risk score. Obviously, we cannot talk about application without talking about data and data categories. It's particularly important to identify a correct data classification and the risk score of each single data category. This risk score should also be accompanied by the one produced by the pen tests, A separate discussion concerns business continuity, whose assessments normally refer to processes and not to applications or infrastructures. This frequently represents a problem because it often involves a non-alignment between the assessment of business continuity and those of the various risk scores, especially of the IT risks. Not all companies have the problem of fraud, but for those that do, this factor should also be linked to the business processes. The mobile component of the infrastructure deserves a separate discussion, which is normally neglected in safety assessments, and which represents one of the areas of the greatest danger for the company. Finally, the human factor should also be considered, which is difficult to quantify. All this to promptly identify the attack surface and then arrive on an overall assessment of the maturity level in terms of cybersecurity. When we started talking to our customers about our holistic vision, the most forward-looking enterprising ones supported us, asking us to apply our idea to some of their specific requirements. In this way, some of the first HOLOS modules were born, for example, SAM or MCube, which we, however, developed not as a custom component, but as an object ready to be adapted to any reality and application, for example, the normalization, in view that the winning move is the idea, the approach, and not the single requirement or application. These were the first modules that have been requested by our customers. Anti-fraud monitoring, mobile security, MCube, security asset management, system administrators compliance, a regulation from Italian Data Protection Authority, banking transparency, another regulation from Italian Data Protection Authority, risk hub, ETS Deep Information Manager, PNSC, Italian National Plan for Cyber Protection and Information Security. The HOLOS architecture is a classic architecture of a Splunk development. We always start from data sources, which can be either from online systems such as anti-fraud systems, or from more or less static archives present in companies, such as CMDB, APM, or the taxonomy of processes. All data are acquired using technical add-ons which perform normal activities of input, parsing, and normalization. The acquired, parsed, and normalized data are then indexed and enriched using the incredible functions of Splunk. Among the various enrichment, the trend processing done using machine learning deserves a particular mention. A further enrichment to the data contents can also come from specific databases, also described in detail in a subsequent slide. Having therefore available all the necessary data, it was possible to create the individual apps that make up the various HOLOS modules. Therefore, the dashboards, navigation, correlation rules, and data quality control rules. These features are also described in detail in the following slide. To complete the architecture, there is the component of integration because every system obviously does not live alone, but must be integrated into the operational reality of the customer where it works. We have tried to use standard add-ons as much as possible, identifying in the Splunk base all those that could be of interest, for example, Tenable add-on. But in some cases, we had the need to develop some custom ones, specific for some data sources, such as the risk quantification from MasterCard CyberQuant. Obviously, it was necessary to create specific add-ons for the data coming from the customer information systems, which most often resulted in the acquisition and processing of data in CSV format, but which required the definition of a ruler definition to be transferred to the information system of customer. For example, do not use spaces or special characters in the names of the fields, define the data download methods, incremental or full, and so on. The integration of the enterprise security asset risk score data obviously deserves a separate mention, which being a Splunk product generates easily usable data. Even if, to be honest, none of the customers where Olos is installed also use enterprise security. But of course, we are ready to integrate this data. As already mentioned, there are specific public or paid archives containing useful information to enrich or provide specific information functionalities useful to some Olos modules. For example, the MCube module is enriched through the presentation of specific information bulletins of threats to the mobile world, or the cyber risk quantification uses trend landscape information made available by MasterCard CyberQuant. Some of these archives have already been used, but in any case, the Olos application architecture is open to further integration to other enrichments. Updating the data from the customer's information systems was one of the first problems that we had to solve, because often our customers have asked us to be able to send us the entire archive, for example, the entire process taxonomy or the entire CMDB, and obviously with different frequencies from archive to archive, and with the possibility that some downloads could be skipped. Since Splunk is not a database, we faced the problem of identifying the latest version of the data available and using it to always display the updated version of the data, regardless of when it was downloaded. Obviously, always maintaining the history of the updates. We solved the problem by implementing a specific macro that quickly identifies, so as not to overload the searches, the latest version available. Obviously, a parametric macro that did not burden the development of the SPL code. This is the macro we implemented. It is called by passing the reference event type, for example, the taxonomy or the CMDB, as a parameter. A very fast sub-search is then performed to identify the last loaded event. In this way, it was possible to identify the earliest parameter, such as the timestamp identified in sub-search minus an hour, and the latest parameter, such as the timestamp identified in the sub-search plus an hour. In this way, it was possible to identify and filter only the events of the last download, regardless of when this occurred, maintaining a good level of performance. Normalization is a concept that is certainly clear to all present, and which is normally applied to the data sources using standard TA-CIM 4.x compliant or higher. In our case, it's a question of adapting different record layouts in the form, names of the fields and values used, to those set in Olos. In this way, it has been and will always be possible to easily integrate with a few simple steps an analogous data source. The steps for normalization process applied to our case are simple. Define a record layout, field names, for each Olos archive. Analyze the information of each new data flow. Define on paper the field renames to align the new data flows to the Olos record layouts. For example, CD underscore asset as new CD asset, changing the uppercase in lowercase. ABI as new ABI code, changing the field names and the cases. Define on paper the field transformations to align the new data flows to the Olos record layout. For example, assign a predefined value to a field. Apply renames and transformations in the Olos app. I would like to point out that all the first steps must necessarily be designed on paper and not directly on Splunk to avoid forgetting any of them. As you can see, we implemented many different normalizations for the same kind of data. As you can see, APM or CMDB, because we receive data from different systems with different field names, sometimes only upper or lower case, sometimes completely different field names. At the same time, we implemented also normalizations on some values. For example, on 0365 source type, tenable. The same procedure should also be applied to the correlations between the archives to implement. Analyze the information of each data flow. Define the correlation keys drawing the entity relationship diagram. Identify the situations where it could be useful to create a table correlating the data flows. Create tables correlating the data flows. Use the correlation keys in searches. Also in this case, the analysis should be done first on paper and then applied on the system. This is an example of the application of the correlations that has been done on the archives present in the Security Asset Management app. I don't think I need to explain in detail how it was set up. In this module or app, if you prefer, there are 5 different archives with some keys in common. Sometimes the same key also has different names. But the presence of these unique keys allows navigation from one archive to the others with ease. Identifying, for example, which assets are used for the execution of a certain process, although there is no direct relationship. Or it's possible to compare the contents of the business continuity archive with that of the IT risk to highlight any inconsistencies or deficiencies, which in fact we found when we applied the system to the bank that asked for it. As you can easily suppose, in carrying out the quality control activity, and above all, the alignment of the database, there will certainly be the problem of the management of false positives. In few words, those data that, for example, have no connection with other data, and this is correct. It's not an anomaly. Obviously, it's not possible for the control to detect this situation, and this check is reported every time as an anomaly. This could affect the quality of the control itself. There is therefore a need to record such situations to eliminate false positives in future checks. This is obviously a time-consuming operation, at least the first time, but it will be particularly useful in repeating the checks. This would be very simple using a database. A simple flags on the record would be enough, and that's it. But Splunk, it's not a database. It's an event manager. So how to create a whitelist of data not to be reported as false positive in a subsequent check? The solution implemented, as you can suppose, was to create some lookups to record the whitelisted items. These lookups, based on a key store, are specific for the individual archive to be checked, in the some specific case, taxonomy and business continuity, and then create some specific dashboards in which errors emerging during the check are reported, and with the possibility of putting a flag on each of them. In the dashboard, there is also JavaScript that updates the lookup launched by a button to save the whitelisted items. The lookup is then recalled both in the anomaly display dashboard and in the alerts implemented to filter the anomalies found, so the false positives are eliminated from the results. As you can see with this dashboard of the sum up, it's possible to display all the values in a table, taxonomy in this case. The second column from right indicates if the value is whitelisted or not. Clicking on the row, it's displayed in the bottom panel. So it's possible to assign the yes value and a note to the displayed row, for example, a justification for the whitelisting. Then it's possible to accept the update with the click on the Save button. There is also a confirmation window that obviously possible to disable. Then the table is reloaded and the value is updated. This is possible calling a button in one HTML panel that calls a script called run_action.js that executes the lookup update. This is the script. As you can see, the script takes all the values from the above panel containing the values updated from the inputs. Then it builds an update search. And then it runs this search that updates the lookup. For this script, I must thank a colleague present among the participants in this meeting, Mauro Bissante, one of our Splunk specialists who developed the script. After all the preparatory phases I have just described, we have finally arrived at the actual development phase, even if some hints have already been given during the design phase. Here, I would like to highlight an aspect that I believe each of those who have developed something in Splunk have already certainly identified. 100% of any job to do with Splunk, 70% of this work is represented by knowing what to do. In other words, knowing the topic or technology to use, having clear objectives to be achieved. In short, doing everything I have described so far. Then only 30% of the work is to apply what was designed on Splunk. In this way, I don't want to reduce the importance of the work that me, my colleagues, and all the people who work on Splunk do every day. But the tools that Splunk makes available allow a simple realization of what needs to be done. I have highlighted this because I don't think that there is only Splunk specialist. A person who works on Splunk must necessarily know, at least superficially, but better if deeply, the technologies or issues he is facing. So, as I said, the first step is to know what the topic or technologies being monitored, and therefore plan the following technical activities on paper. Identify all the requirements, in other words, the use cases to implement. Identify all the data sources containing the data to use. Analyze those data. Identify normalization, if present. Identify correlations, if present. Define all outputs, dashboards, reports, alerts, avoiding designing dashboards while creating. Define navigation rules, menus, links between dashboard, drill downs, and so on. The last point is one of the most important to avoid repeating many times the same work. I repeat myself, I don't want to diminish the work that me, my colleagues, and all the people who work on Splunk do every day. but the tools that Splunk makes available allow a simple realization of what needs to be done. Knowledge and experience on Splunk is very important in this phase of the work, especially with the view to creating functional, well-structured, and easily maintainable objects. This is a very easily and frequent mistake to take with Splunk precisely because of the ease of obtaining tangible results with this fantastic solution. Therefore, avoid approaching problems without an adequate preparatory phases of analysis and planning of the intervention to be carried out. Then, again, thanks to Splunk, there is always time for changes and optimizations. So, the steps in development that all of us experimented are: set up inputs, create normalizations if present, create correlations if present, customize dashboards, reports, and alerts, customize navigation, menus, link between dashboards, drill down, and so on. We therefore arrived at the real realization phase, the one in which my colleagues and me committed ourselves and in which we created, one after one, all the various components, the bricks, which make up OLOS and which, for the most part, are also already in production at our customers. I'm not speaking about philosophy, that I love anyway, but about real, concrete, and functioning realization we did and continue to do. These are the modules or app that we developed in these last years. OLOS Fraud for analyzing data from the various components of the anti-fraud system. OLOS Security Asset Management for the correlation of different archives related to the security asset management. OLOS Risk Hub to display and compare risk assessment performed with different systems or tools. ET Assets to correlate information from the system extracted with Splunk with the assets management data. Asset Mobile to correlate data related to mobile devices from mobile device management systems and mobile threat defense systems. OLOS Compliance to give the evidences of compliance activities in use in the company. The structure of OLOS is modular, in the sense that each single module has a parent module, which is a very simple app and contains only the home page and the menu, which acts as the main menu for all the other components, and from which it's possible to reach the individual components, the apps. In each component, there is an home page and the component's own menu. There are all the dashboards and objects to respond to the reference use cases, and then there is always a menu item that allows reverse navigation and then return to the starting module. As already mentioned, in each component there is a summary home page, which presents the summary data of the use case managed in the component. Then there is the possibility of navigation through the menus and/or through specific links in drill down. There are therefore specific objects, dashboards, reports, that promptly respond to the use cases to be implemented. For example, the priority list in the ET Asset Deep Information Manager app, or the use case for viewing the network shares obtained with the ET Asset Deep Information Manager app, or the use case for viewing all the asset information obtained with the tenable scan and managed with the EIT Asset Deep Information Manager app. The last development activity that we had to face was integration with company information systems, for example, the ticketing system or company security monitoring system, such as SIEMs or SOARs or platform as threat intelligence. It should be noted that these systems can both data sources for OLOS and receiver of all analysis at the same time. Finally, integration with the mobile access system. We have now concluded the quick overview on our holistic approach to data integration, which, as you have seen, is not a poor mental rumination, but a solid and concrete realization already in production with some customers. I will now briefly show you some of the implemented use cases, both in terms of implemented functionalities and in terms of implementation methods that underlie. The first use case, which was mentioned several times during the presentation, is that of security asset management. This is an application that was requested by a leading Italian banking group. Their need is that they have 5 distinct archives in use: taxonomy, business continuity, IT risk, application portfolio management, CMDB, which should be correlated with each other, as they all pertain to all the operations and information systems of the bank, but made in different and unrelated application environments, therefore without the possibility of a structured navigation through this data. Therefore, in a nutshell, the requirements to be met were: browsing through the archives to be able to correlate the data of one with those of the others. For example, identifying the assets relating to a specific process or which processes were related to a specific asset. You easily realize the importance of such information, for example, for the preparation of business continuity plan. Furthermore, we were asked to check the quality of the data contained in the various archives, and above all, the alignment of the data between them. For example, in the specific case, a significant misalignment emerged between the data contained in the business continuity archive with that of the IT risk archive. The solution implemented for the bank was based on 3 of the components of HOLOS. Value chain to allow correlation and navigation between archives. For example, display the assets pertaining to a certain taxonomy process or identify all the processes that use a certain server. Data controls to carry out data quality checks and data alignment between the various archives. Case manager for the management of the reports that emerged from the previous module without overloading the bank's ticketing systems. Obviously, the components use and rely on Splunk. I will now show you our realization. As I described above, every app starts with a home page that summarizes the numbers of the use cases. In this case, there are quantities of business processes, business continuity evaluation, IT applications, IT application risk evaluation, IT assets. For data classification, we're ready to integrate, but customer wasn't ready. In the bottom of the dashboard, there are some main statistics to evaluate the situation. Clicking, for example, on business processes, there's a dashboard that permits to navigate on the company taxonomy tree. Then choosing a value, for example, this, I can display all the information from the other archives related to this process. Process details from taxonomy archive, risk details from the taxonomy archive, organization details still from a taxonomy archive, apps in taxonomy archive used as correlation key, business continuity enrichment process phase from business continuity archive, APM application details from the APM archive. There can be more than one application related to one process, so I can choose the application to continue the navigation. For example, the first. In the bottom of the dashboard, there are the list of the assets related to this process through this application. Then in the bottom of the dashboard, there's the risk level for that application from IT risk. Clicking on one asset, this for example, we have information from the vulnerability assessments on these assets. So the assessment that we made, asset information, authentication information, data leak, no data, remediations, shares. The navigation is possible starting from one of the other archives, arriving to all the others, for example, from CMDB or from business continuity to each the others. This dashboard displays all the available correlations between archives starting from the app code, the correlation key. For example, APP0017 is correlated with business continuity, with CMDB, with taxonomy, and with IT risk. As second use case, we have risks. This app was born from my personal experience as an auditor and from that of my company as a consulting company in the field of governance, risk, and compliance. But what is the context in which this module is born? That of the need of companies, practically all, not only to be compliant with the requirements of some standardization frameworks as ISO 27000, but above all, to be able to demonstrate it, both in management and above all in audits. The problem arises mainly because there are many sources of compliance assessment data, but normally separate, not integrated, and with different measurement, and above all, quantification methods. So compliance officers and IT managers have a hard time reading this data and presenting it to auditors. So what were the requirements that we found ourselves having to meet? First of all, the presence of results from multiple products that there was the need to present in an integrated form in a single console. Therefore, we have encountered the need to compare heterogeneous values with each other, even if they pertain to the same issue or the same control. Produce presentation dashboards and reports in line with the reference standards, for example, ISO 27000. Therefore, have a tool that would allow continuous monitoring of risk over time. For example, not limiting the analysis to a simple snapshot of the moment of the analysis, but showing the trend of the valuations and therefore the growth trends, which are the basis requirements for all methodologies. The solution was therefore Olos Risk, an app that acquires measurements made by different systems, in some cases specialized in such measurements, and presented them in a structured form, allowing both company managers and auditors not only to assess the level of maturity of the company, but above all, to present the evolution of results over time. Obviously, without losing the analytical details of the individual results. All in a single console, without having to continuously switch between different products. I will now show you a quick view of our realization. As usual, I start from an high-level view, arriving to the use case. In this demo site, there are compliance evaluations from 3 systems: Mastercard CyberQuant, Office 365, Tenable. And the output is for the compliance with ISO 27000 and GDPR. As you can see, there are the evaluations from many assessments performed with different systems, some are automatic and some are with the human answers. It's possible to see the details of each kind of assessment, for example, with master quant, having the results for each control. For example, this is the results of a specific assessment made with CyberQuant on a system for a specific framework, ISO IEC 27000, and it's possible to change the assessment, choosing another one, or choose a different framework, for example, NIST. And we have all the results from this assessment. It's also possible to choose a single control, for example, this one, having all the results for this single control for all the systems. It's also possible to highlight the time distribution and the evolution of the results of the control with the difference with the previous one. The last sample that I'll present you is mCube, the mobile monitoring management app. The continuous and growing demand for mobile working brings with it the need to increase device protections. And this project fits into this need identified by a large Italian company in the defense sector. At the same time, the need for protection entails the need for continuous and proactive monitoring of systems to promptly intervene in the face of threats and to have continuous and constant control over the infrastructure and operations. Holos mCube represents the verticalization of the Holos platform for the mobile world, collects and correlates informations and events from device management platform, secure messaging apps, and mobile threat defense solutions to provide a single monitoring and correlation console. The context in which this app operates is a leading Italian company operating in the defense and aerospace sector, with many employees and therefore many thousands of devices to manage and protect, also in view of significant data that staff normally must manage. With use distributed in many countries, located in all 5 continents. In this project, the mCube app, developed on the Splunk framework, is responsible for collecting data from the mobile device management system, in this case Mobile Iron, and from the protection service of these mobile devices, in this case Zimperium, so as to have a broader view on the entire system and on the compliance status of the systems and on the attacks intercepted on the devices managed through the platform. Furthermore, as the company is ISO 27000 certified and subject to European legislation for critical infrastructure, there was a need to produce documentation for compliance with the reference framework, in this case ISO 27000. The solution is mCube. Its main purpose is an assessment of the state of compliance with policies and cyber risk of mobile devices, presentation of the actions performed on the devices divided by type, health status of the devices, visualization of the attacks suffered with presentation of the historical series. In this way, it's possible to have a series of synthetic dashboards with the possibility of analytical vision through drill down, which on the one hand provides a series of alarms in the face of certain situation, and on the other can act as a support for troubleshooting and allow to synthesize and represent usable data that otherwise would not be. By broadening on the horizon of the analysis, the Splunk enterprise at the base of this solution is able to receive logs also on the security infrastructure, so as to have a correlation tool of heterogeneous data sources to be used for extensive troubleshooting, to be able to introduce a monitoring of first level for IT security and proactively intervening on known problems or malfunctions. I will now show you a quick view of our realization. As usual in Olos, there's a summarizing on page that gives an overview on the infrastructure system, left panel, on the mobile device perimeter, center panel, and on the protected mobile devices with an overview of the level 2 and level 3 severity cases. In the bottom of the dashboard, there's an integration with external information data sources, highlighting the last published articles, in this case about Zimperium. Then, as usual, it's possible to analyze data, for example, about mobile devices. The dashboard displays the company mobile devices, obviously with the possibility to drill down to single device information. These are all the Android devices managed by the MDM system, arriving to the single device, single information, one by one. So now I finished my brief description and demo about Olos. There is still some time left for some question, if you like.